This is Bang Goes the Theory. For the next 10 weeks, we're on a mission to get science out of the lab and into your living room. Engineer Jem is going to build, bang, and blow up his way through a series of homemade experiments.
Whoa!
Biologist and biochemist Liz is willing to go anywhere and do anything to bring you the latest research.
Tastes like bacon.
I'm Dallas, and I'm going to put myself in harm's way just to get you answers to some of science's big questions.
Why is this man sticking things to my face?
Oh, God!
I'm gonna eat like
That's Bang Goes the Theory, putting science to the test.
Welcome to Bang Goes the Theory, the BBC's brand new and shiny science show. On tonight's programme, Jem attempts to build his very own supersonic vortex cannon. Whoa. I meet a controversial scientist who claims he may just hold the key to the world's energy crisis. And back here at Bang HQ, we set fire to a homemade tornado. Before all that, though, Dallas and I are off to Southampton. This country is home to over 4 million CCTV cameras. Now that's more per head than any other country in Europe, but it's not quite as efficient as the authorities might like. The technology is incredible, with all those cameras feeding back to secret control rooms like this one. And they're monitored 24 hours a day, 365 days of the year. In fact, this is all such a covert operation that we've got to keep our location a secret and the identity of my friend Barry here hidden. But there is one small problem with CCTV, which I can demonstrate with this suspicious-looking character.
Hi, Liz. You ready?
I'm so ready for you.
Me too. Catch me if you can.
Let's track him, Barry. Okay, he's off. I've set Dallas the challenge of trying to lose me. He's looking a little bit confused, he's looking shifty, but that's normal for Dallas. He's running now. Don't run, don't you run.
Whiskey 12 Mike 8, you've got target Zulu. Description as follows: OC1 male, V-neck jumper.
I was getting quite excited. I thought there's no way they can find me here in the park. I just noticed a giant camera right there.
You look so pretty, baby.
You're creeping me out, Bonin.
Yeah, good effort, but like not even close to losing me.
I'll hide from you yet.
This is better than any video game I've ever played. This is awesome. But if you think Big Brother is watching you, there is one way you could beat him.
I'm gonna get you, Liz Bonin.
All you need to do is change your clothes, grab a friend, and you could be off scot-free. 2 people going in, 1 person going out. That's it, we've lost him. What did you do? Where are you?
Have I lost you?
Tell me where you are.
I'm back where I started from, almost.
There. Look at you! You got a hat on you! That's so cheating. I can't believe you won. That's so annoying.
I have beaten Big Brother / Big Sister.
So, CCTV can fail if someone uses a clever disguise, for example, but there is something really distinctive about you that's a lot harder to hide. It's the way you walk, combined with your posture, otherwise known as your gait. Apparently, it's as individual as your fingerprint, and the hope is if we can make CCTV systems identify people by their gait, then no amount of disguise will ever work. And now the technology to do just that is being developed by scientists at Southampton University. Whoa.
Wow, this is psychedelic.
Isn't it?
This is like kind of early Pink Floyd.
What goes on in here, Mark?
This is our
gate recognition system. It's the only one in the world. It's the best, but you could also say it's the worst. It's got 8 synchronised cameras.
Right, what do those cameras do?
Well, why didn't you walk down the red carpet?
Dallas, will you get a grip and do it properly?
Sorry. The psychedelic colours help the cameras capture not only the length of my legs, but exactly how they move. Stick the two together, and incredibly, the computer can instantly tell if it's looking at me, or Liz, or somebody else in its database. Or at least that's what it claims. Is that 3D image? That's like a fingerprint. Like nobody else could recreate that.
Absolutely,
visual fingerprint.
In a sense, a lot of people are similar. We've got a head, a body, 2 arms, 2 legs. It's when you get into the more details, yeah?
Okay.
Because you've got muscles, your legs are slightly different length. It's the combination of all those that gives you the uniqueness.
Can I put this to the test and see if it actually recognises me?
Sure, go ahead.
Over 200 people have walked through this tunnel and been registered in the database. When I walk through again, the computer has no idea who to expect. It'll compare my walk with all the walks it knows and then come out with the top 5 closest matches.
Dallas, way!
Dallas.
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 He's number 1.
Absolutely. Awesome. Can I try mine?
You're welcome, go ahead.
Okay.
The genius of this system is in the 3D model it creates. It can recognise someone's gait from any angle, so ultimately it could identify me from any CCTV footage. Right, my gait's logged into the system from the first time I walked through. Will it know me this time around?
See?
Wow.
Yay! That was even quicker.
Well, no, Lee, you and Lee are quite similar.
Don't take it personally.
Lee could be a girl's name.
It's
Hold
to
on,
Lee.
I want to find out, is Lee a man? Can you tell me that,
No, Lee
please?
is a man, yeah. But is
I
it-
walk like a man.
Can I just try one more thing, just really, really quickly?
What?
Just a little scientific experiment.
What are you
Just
doing?
have a look at this.
Oh. Oh, for goodness sake. Dallas,
Oh, that's really annoying. They meant to cut that bit out.
do you
at the
see
end. That
what
was-
happens when you mess about?
Yes.
Dallas, at least John Cleese has a little bit of competition there.
This is true. OK, now then, one of the things we want to do every week on this show is to attempt an overambitious and foolhardy experiment, and the man in charge of that is Jem.
Oh, yeah.
Yep, this week I intend to take this fairly unimpressive little piece of kit and turn it into a weapon that could do what the big bad wolf never could. Blow down a house of bricks.
Now, I know this is basically a tube with a hole at one end and rubber at the other. But here's the basic idea. If I tap it ever so gently, it produces beautiful little smoke ring vortices, and they remain very stable as they travel through the surrounding air. Nice, eh?
But look at that, perfect. I can see if I can get one in.
This is a lovely little bit of aerodynamics. What happens is as the blast of air emerges from the tube, it gets wrapped up into this donut shape. And that donut shape is able to transfer the energy of the blast incredibly long distances.
Okay.
Love it.
It is good. But it's not great. What I want to do is make that bigger, faster, stronger, and a whole load more powerful. Smoke rings might seem like a pretty gimmick, but they're actually a fascinating piece of aerodynamics. What happens is a blast of air gets dragged back at the edges and folds itself into an incredibly stable, swirling donut. It's just, how do I get that to happen at explosive speeds?
My challenge is going to be to create a vortex with a really powerful explosion. That means the air forming it will be travelling faster than the speed of sound, which totally changes the way it behaves.
If I'm going to do it with a big explosion, I fancy trying to understand a small explosion first. That's why I'm using the bursting of a balloon.
But producing even a small vortex ring with an explosion isn't easy.
Nothing. That suggests to me there is no vortex coming out of that. That's just a turbulent tumble of air. Absolutely no ring-shaped vortex. Plan B. I've discovered a neat trick. Adding a barrel to the same piece of kit seems to smooth out the airflow, producing that all-important vortex ring.
Although we couldn't see it, I'm convinced that that was a vortex ring.
Now, I just got to scale it up to as big an explosion as I can handle.
What I'm aiming to do is turn those delicate little smoke rings into high-speed battering rams. After hours of experimentation, I think I've discovered the perfect design for what, when scaled up, will become my massive vortex cannon.
This is the final prototype for our vortex cannon. It's powered by a mixture of air and one of the most explosive gases on Earth, acetylene. I make the explosive gas mix by injecting acetylene through this little hole in the back. I then ignite it by creating a spark between these two screws. But the key is this conical barrel here.
It allows the expanding gases to expand in a smoother, more controlled way. Just the best conditions to create the most stable vortex ring possible. That's the theory, but let's try and put it to the test and knock over this bottle from 20 feet.
I've calculated I need 125 millilitres of acetylene in here to produce the perfect mix. When this goes, it will produce a supersonic shockwave. The thing is, can my barrel turn that into a ring-shaped vortex? Here goes. Whoa! Yes.
Pretty good, but I promised I was going to knock down a pile of bricks. So I'm going to scale up the prototype by more than 150 times, and if it works, we might just be able to see a vortex ring. It's something I've never tried before, and I'm not sure if it will really work. So let's just hope the late nights are going to be worth it.
That is one of the trickiest builds I've ever attempted.
Yeah, it looked hard. Is it going to work?
You'll have to wait until later in the programme to see that, but I am going to show you something else. Do you want to see
Okay.
another kind of vortex? This one from nature?
Yeah.
You ready?
Yeah.
Come on,
Okay.
Dallas, I'm going to show you a homemade tornado.
Let's go.
Now here's a good fact for you. When you think of tornadoes, you probably think of the big twisters in the American Midwest, but there are actually more reported tornadoes in the UK per square kilometre than there are in America. They're just less big and impressive.
We don't mind a bit of a challenge. So right here, we've got our own homemade tornado machine. Now in a real tornado, it's just a spinning mass of rising air. So to cause our air to spin, we rotate this mesh, and to get it to rise, we set fire to it.
Have you got any idea what you're doing, Jem?
I've-
Or are you just making this up as you go along? That's what's happening.
It looks too homemade. I know what you're saying, Dallas. It'll be fine.
Jem, I am definitely not fire retardant today. I've got loads of hairspray in my hair.
That was your choice, Liz.
Yes, I know. I'm just letting you know.
You'll probably be okay, Liz.
You promise.
That's it. Now it's alight, the heat from the fire is causing that spinning column of air to rise. And just like in a real tornado, that rising, spinning column of air sucks in cold air at the base. Now here, that cold air feeds the flames and makes the vortex even more intense.
That's good, actually.
It is beautiful.
Great.
I love it.
So, Jem, essentially, you're a fire starter.
A twisted fire starter.
Maybe just some kind of scientific prodigy.
Excellent stuff. Now, if you want to get your hands dirty with some experiments at home, although they might not quite be as big as this one, go to our website, bbc.co.uk/bang.
Now then, one of the things we really want to do on this show is to explain the science behind the headlines and also meet some of the scientists who are making them. And this week, Liz went to meet someone who I think is fair to say divides opinion.
Oh, yeah, a lot of people have a serious problem with what this guy is doing. He thinks his work is absolutely essential. He also thinks he might just have the answer to our planet's energy crisis. Take a look at this. I'm heading to possibly the most controversial research facility in the world. Now, I can't tell you exactly where I'm going because a lot of people are dead set against both what's going on out there and the man who runs the entire operation. Craig Venter was one of the first people to decipher what makes us people and not, say, dolphins or seaweed. He jointly sequenced the human genome, the complete set of genes that is unique to humans.
And Venter is now taking that genetic research one step further because he wants to create new forms of life. For some, Craig Venter holds the answers to our world's future. But to others, he's Frankenstein, a scientist playing God.
Well, we're trying to understand basic life by learning how to now write the genetic code. So we start with the digital code in the computer and 4 bottles of chemicals, and we actually build the DNA molecule from scratch.
So you're designing a genetic code on the computer, and then you're actually making it in the laboratory.
Exactly.
And I'm sure some people would be very scared of that notion.
Some people prefer to live in a cave and work with whale oil lamps, right?
Is there any danger that in the future they will harm the environment or harm us because they're not natural living beings?
If irresponsible scientists design things to go into the environment, yes, I think that's always a potential danger. One of the rules that we've tried to establish is that nobody makes anything that could survive in the environment on its own.
To help in his quest for new life, Craig Venter is taking his boat, Sorcerer 2, on a high-tech mission around the world. Combing the depths, the controversial millionaire scientist hopes to find unknown species whose unusual genes could be the basis for new synthetic life.
So, do you reckon there are like many new species just on this filter paper alone?
85% of what we find is totally new.
That's pretty incredible.
So that means there'll be lots of new ones here, and thousands or millions of new genes. So
that's amazing.
We've discovered now about 20 million genes. So before we started the expedition, there was only about 1 million known to science.
20 million genes already you've discovered just from the ocean?
Just from these filters off this boat. Wow. So the majority of genes known to science came from this vessel.
Now the big question is, why is he doing this?
Knowledge and science is not just a nice thing to have. It's an absolute necessity now. So we have 6.5 billion people on the planet. In 40 years, there's going to be 9 billion people. We can't provide food, medicine, clean water, and energy for the 6.5 billion. We have to have new science, new knowledge to be able to survive.
The controversial scientist even claims his new life forms could be the answer to the world's energy crisis.
These are the organisms that capture CO2 back from the atmosphere. These are the organisms that actually make the oxygen that we breathe. Some of these same organisms could be the solution for future energy, new ways to capture back CO2, new ways to make fuels instead of burning oil and coal. Now we can genetically modify to have them do that process much more efficiently.
But obviously there's going to be people who are saying, you know, you're playing with life here, you're making new synthetic organisms. Is that really moral?
It's absolutely moral. It's immoral not to do this work because it's such a dire consequences if we don't have some new solutions.
Why, in your eyes, is this the only way forward? I mean, why is it clearly just the way to go?
Well, it's not the only way forward, but biology is the only one that's truly scalable in a short period of time to have a big impact.
It's not often you meet a man who literally could change the world, and this kind of research is truly revolutionary. Like him or loathe him, Venter is pushing the boundaries of science, and with it, may just shape the future of our planet.
That was such an interesting film. Having met him, are you a fan, do you think, of what he's doing?
I'm really fascinated by the whole subject, and there's no doubt that the implications for medicine and for science are huge. Essentially, natural selection is all about selecting for the useful genes. Geneticists are kind of speeding up that process, and when you think about it, it's already happening with selection for more productive cows or bigger and better crops. But what they're doing now is taking that technology and pushing it even further. So they're cherry picking genes from different organisms, placing them all into a new organism that they have created. So they're essentially creating new life forms.
Exactly. You know what? And that's the thing that I think some people are going to get a bit scared of.
Yeah, of course, no doubt about it. But you know, we got to know about this stuff because it is happening now, and people like Venter are changing the face of science literally as we speak.
Yeah, exactly. Now, there's a fourth member of our team, Dr. Jan, but as you can see, he's not here. So vast is his intellect, we couldn't actually fit him into Bang HQ.
Yes, indeed, and that's why instead we sent him on a one-man mission to bring science to the high street.
Apparently, he can cook.
Ooh.
The question is, how on earth do you fry an egg over a stove if you haven't got a frying pan? I'm not entirely sure what we do. Maybe we leave it for a little bit and see what happens. Oh! That's not too bad. Would you eat it?
Not too sure about that.
Do you want me to show you a different way of doing it?
Yeah, go on then.
Okay, so you can do it with paper. Oh! I'll show you.
I've got a daily mirror here if you want.
Oh, yeah, go on then. Yeah. I'll do it with a mirror. Do you want to?
I want to see this, man.
You think it'll just burst into flame, right?
Yeah.
Just in case,
Okay.
isn't it?
Burning, it's just a chemical reaction, and it takes a certain amount of heat to get the reaction going. That's because it takes energy to break apart long molecules like those in paper. In fact, it takes quite a lot of heat energy to make paper spontaneously burst into flame. Its ignition temperature, as it's called, is about 232 degrees centigrade. That's Fahrenheit 451. So if I just put some oil in, and treat this like a frying pan, like you would let any other normal frying pan, put an egg in it. So do you think it's going to burst into flame?
I thought the paper would go boom. I trained as a chef 20 years
Right,
ago.
okay.
It's
They
the
didn't
first
teach
time
you
I've
like
ever seen
this.
this.
Bubbly. Yeah.
Yeah, it's frying, look. Yeah, it's cooking. Yeah, it's cooking.
Perfect.
Well, the egg is absorbing the heat and keeping the paper below that critical ignition temperature, but still quite hot, enough to fry the egg. That's probably done now. Looking all right to me. Shall I give it a try?
Yeah.
That's
That's amazing how that's done that.
Oh, you're clever, you are.
I'm quite hungry actually because I haven't had any lunch yet. So
That's not edible. I wouldn't.
really nice. Okay. Yeah.
That is delicious, actually.
Fun.
I'm going to give that a go.
Loving it. Are you going to try that?
Yeah, definitely. You know, the really annoying thing is I just bought a very expensive frying pan and they needn't have bothered if I'd realised you could have just used a bit of A4.
Feeling your pain, Dallas. Anyway, if you want to see more Jan experiments, test him with a killer question at /bang.
Yeah, our pocket science genius is going to be online and on a mission to answer your science-based questions.
He is indeed. Or if you prefer your science a bit more up close and personal like I do, you can also find details of how to see Jan in action face to face at our Bang Goes the Theory roadshows. Now this week we're live and interactive at the Harbour Festival in Bristol.
Yes, we are. In fact, all summer we're going to be travelling up and down the UK with loads of experiments and a free science show. So come down and get your hands dirty.
You can find the details of dates and locations on our website. But right now, I'd like to drag you back to my world, a world obsessed with vortex cannons.
My prototype vortex cannon flew a bottle into a bin from 20 feet. But I've been working day and night to go a lot further and do something that this country has never seen before. I've taken a huge risk and scaled it up. What I'm hoping to do is produce a vortex ring so powerful that it creates a visible ring in the still air around it.
An enormous amount of thought and experimentation went into creating this, a vortex cannon. A 1 litre explosion goes off in here, it drives high-speed gas down there, and a perfect ring vortex emerges from here. We love it, but not as much as this. 150 litres of exploding acetylene and oxygen comes down here, 12 feet of steel barrel, and emerges there at a 3-foot aperture as a perfect vortex ring, I hope. Now, the power of this is an unknown quantity, but here in this quarry, we're going to do a whole series of experiments and find out just what we've made.
The ultimate challenge is to produce a visible donut of air so powerful that it will do what the big bad wolf could never do: take out a wall of bricks. But just like in the fairy tale, we'll start with something a bit lighter.
According to legend, a really good blast of air should be able to bring down a house of straw. Let's see how it goes with an explosively generated vortex ring. Here goes. This is the gas.
It's the first time it's ever been fired, and with 150 litres of one of the world's most explosive gas mixes in there, I'm not even sure that this is really a safe place to stand.
Seems about right. I'm going to need these, I reckon. Here we go. 3, 2, 1. Oh, yes!
Call me hopeful, but there was definitely something there. But was it a vortex ring? Filmed at 1300 frames per second, there is no doubt. But the ring you can see is not a smoke ring. It's formed by the pressure drop within the vortex, condensing the water out of the damp air above the lake. A 200-mile-an-hour cloud.
Ho, ho, ho. Bring on the sticks and bricks. 3, 2, 1. What? Yes! Fantastic! Well, it makes mincemeat of a house of sticks. Bring on the bricks. Even in fairy stories, they couldn't get a blast of air to knock down a house of bricks. We're heading into the world of the unknown a little bit, so we've got to experiment. We're going to try changing the elevation on it, changing the gas mix in there, see if we can get a perfect gas mix. So that's just the right amount of molecules of acetylene reacting with just the amount of molecules of oxygen in the air. So there's no passengers in there, it's got to be all explosion. Let's see how that goes. Three, 2, 1. Hey! Yes! That's incredible!
That was amazing.
I so
Seriously.
loved your reaction at the end of that. That ring looks so perfect. Honestly, you'd think it was like a special effect or something.
I gotta say, it was frighteningly real. And loads of people didn't think it was gonna work, and I was utterly overjoyed when it did.
I can tell you're a real happy bunny about that. On that heroic note, it is time for us to go, but what are you guys up to next week?
I'm going to go and find some alien life.
Oh, no,
like
Dallas,
you do.
really? Seriously?
No, seriously. I'm going to NASA. My new friends.
All right, fair enough. And what about you, Jem?
I'm gonna be trying something that requires a shocking disregard for personal safety.
Good. Dare I ask what?
Yes, I'm gonna be attempting to build and fly my own water-powered jetpack.
Nice.
Whoa. And I am actually going to fulfill a pretty big stereotype by cooking for you both.
Oh, good.
Thanks, Liz.
What's on the menu?
It's a secret, but I can tell you it's going to be challenging cuisine. I can promise you that for sure.
Whilst we're on the subject of stereotypes,
Yeah.
could you iron my shirt?
I'm not even going to answer that question.
kidding, I'm
Just
just
say
kidding.
goodbye.
Bye.
Bye.
I'm kidding. Think it's only reasonable.
You can find all the highlights of tonight's show on the website, bbc.co.uk/bang. And to find out more about the making of Bang, follow the links to the Open University.
Are you going to have to put your earplugs in because it is amazingly loud?
Okay, hang on, not ready.
I'm ready.
Yeah?
Okay, ready.
Right, it takes a couple of seconds for it to go. You ready?
Yeah.
3, 2, 1. Oh my life.